Welcome back. Monday. I've put power on. Most of the spaghetti goes to the appropriate places now. I've actually just double-sided taped our Link map sensor on there for now. We will be doing a new inlet manifold and I'll make a mount for it at that point, whether it's rubber mounted or whatever, we'll figure out. But for now, that will be sufficient. The double-sided tape's quite thick and will provide some dampening for vibrations and stuff. Certainly the real high-pitched stuff will be dulled down a little bit. No insulation on all the wiring and stuff, and it is just a little bit of electrical tape and cable ties to hold it in place while we make sure I've done everything correctly. It's all in the general area of where it needs to be. Our laptop's hooked up to its communications cable there, and we've powered it up and we've unlocked the ECU. And the first thing we found was there was a fault. I'll use that term loosely. There was a fault with the throttle. The throttle position sensor sub was declared broken. She no good. It's dead. ECU didn't like it. There was actually nothing wrong with that. I'd entered some settings in here that were not correct. Put that into there. So that was seeing voltage that it didn't agree with based on its tune that it had, its settings that I'd put in there. All I needed to do was look at the actual runtime values, where it was all going based on what the throttle position was, and adjust my errors, the maximum and minimum errors, and recalibrate it, and it was good. That was that fixed. Everything so far appears to be good. We've got currently, but we'll sort it out, we've got no communications with our Dash 2 Pro, and we've got no communications with the CAN Lambda. Now CAN stuff can be, I'm not trying to use that word many times, it's just the way it's spitting out, is sometimes difficult to set up for some people, and I'm no exception, okay? I'm not a genius when it comes to CAN stuff. We managed to get it going last time with the G4 Plus after a little bit of a headache and a bit of help from the good guys at Link. It was a real simple error. We were trying to set it up on CAN 2, which is the stuff which is found on these plugs here. Or one of those plugs, plug A, I think is on that one there. We could look. We're not going to. It's the grey wires that go from one of these plugs. And the issue we had with the original ECU is it was wired into CAN 2 and we were trying to set it up to run it on CAN 1. I thought that CAN 1 would be the ones that would be on the main plug, but it's not. CAN 1 is on the other plug down in here. So I know for certain this particular ECU, CAN 2, is these wires, wherever they are, they're in there somewhere. And I've set everything up on there. I've not set something correctly. I've done something not right, and it's not going yet. But we will get to the bottom of it and figure it out. It's good to figure these things out myself, because then if it goes wrong next time, I'll know what we're doing. This is not the permanent resting place for the spaghetti that you see here, and all this stuff will be covered up. And once we know that everything's working properly. Something lovely turned up today to go with our beautiful shift lever there. It's been a little while coming on the couriers. We'll unbox this beautiful thing. We'll scratch my carbon fibre roof. That's fine. I don't care. We're not worried about that. If that was a customer's carbon fibre roof that was in better condition, we'd obviously be looking after it. My car, not so much. Inside this bag here is our shift cut knob. And try not to drop it while I'm doing this. Look at that. Isn't that beautiful? And it's got the little, somewhere in here. It's probably on the other side of the bag. There it is. Our, I guess you call them the mini Deutsch connector. And the corresponding buddy for that. Which is good. There's a few of those kicking around in the car. They're actually the same plug as what's on our map sensor there. That's the same style of plug there. So we do have a few spare pins for those, which is quite handy. So for now, seeing as it's, oh look at that, it's nearly 5 o'clock, excuse the flicky lights, I'm going to install our shift cut knob. So I've read, put this away, shall we? I've read and fully understood the instructions some time ago, and because I'm tired, I've completely forgotten. But I think the basics are pretty simple, so let's get on with that. Step 1, sit in the car. It'd be easier if this thing was left-hand drive, because then this would be on the right side. Step 1, 2, are we up to 2? Remove the original knob. Quite a lot of thread on that. Remove the original knob. There we go. Pretty sure that comes out as well. That's actually why it's taking so long, because we were screwing 2 threads at the same time. Yep, we won't need that anymore. Can quietly screw that in there. Okay, let's start with that. The instructions said that this has to be positioned correctly, because there's a load cell in here that will give reading based on the force that you're applying to the knob. And there is a backwards and there's a forwards, because you want to see positive voltage one way and negative voltage in the other. It's a little insulator to stop heat going into the mechanism. So you can imagine if it's supposed to be orientated, I think that is actually it. Just by fluke, I happen to have picked it up in the right spot. Pretty sure that has to be poking out the left hand side, but we're going to have a look at the instructions, which are in my laptop there. If that's the correct position, so down, up, those would be the forces that would be on the knob. Imagine if you put it 90 degrees, you're not going to get any readings from it at all, are you? Ugly white legs are those. And if you put it backwards, let's say that way's backwards, we'll check the instructions and see which way it's supposed to go. Then you're going to get the readings the wrong way, and in some ECUs you may not be able to set that up correctly at all. It may not work at all. So what we'll do is we'll fit this, and we'll make sure it's in the correct orientation. If all else fails, read the instructions. Look, there, looks like that. Right. I'm not sure this is supposed to be public knowledge, so I'm going to read in private. And then we're going to figure out whether that's in almost the right spot. I reckon that goes to the side here by my memory. That's actually what the image is showing, but that might not mean anything. This gap around the bottom here, that is perfectly normal. As that knob moves in relation to that to operate the strain gauge that's hiding in there somewhere, that actually makes everything work. That there thing there is screwed onto there. Without that there thing there. Okay, so I read the instruction manual and I was entirely incorrect. When I was saying to put it out the side, that's exactly where you don't want to put it. It's supposed to go, bad camera work, it's supposed to go out the front. So we can put that in there now. Push that home. That's home. And then you eyeball that as close as practical, a little bit out, doesn't matter. Focus is not very good, is it? And we tighten up all these. And that's it, it's done. And through the magic of modern technology, all the electrons jump from there into there. That knows exactly what to do, and it all works perfectly. Yeah, well, this one must be one of the ones where the Magic app wasn't installed at the factory, so it didn't go. So we have to use some of these tools again, and hook these electron carrying conduits into the appropriate plug. We've got gearbox temperature here, which goes onto this one, which needs a 5 volt pull up onto that. And we've got an earth, which needs to go to the gearbox position sensor and the other side of the gearbox temperature sensor, which is this wire here, these wires here, either or, doesn't matter which one's earth and which one's the sense wire or sender wire or whatever you want to call it. We've got 12 volts. We're going to put 12 volts into there. We're going to put an earth into there, the same earth. We're going to daisy chain that. That'll work fine for this system. And the one that's left over there is an auxiliary input, analog input rather, and that goes into that plug as well. Then we plug that into that again, and we turn it all on, and we make some settings, and then we look at our runtime value. We pick up our wires requested, committed hurry curry, and then we can start moving the stick and seeing if we're getting the appropriate readings in the thing to make the thing stop so that the other thing can change gears. Fun. Plug sorted out. That's that. We've double checked. Well, I've double checked these are all around the right way. We don't want to blow up our brand new shift cut knob. Beautiful thing it is. Alright, so then we open up the old Pooda's thinking instructions here, and we start looking for where to set it up. Now, I've already cheated, I've already opened this up. Normally, with the old G4 Pluses, you would go auxiliary or analog inputs rather, and you'd go looking in there, and you'd find a pin that you want to use, and you'd allocate it to what you want it to be doing. The G4Xs work the other way. So you actually go looking for what you want to do. In this case, is gear shift control. And then you go to gear shift control. And you open that up. There's a whole heap of settings here that we need to deal with later on. And in that list, somewhere here, it's going to tell you source. It's currently set at none. We want to go in here, and we want to use AN Volt 10. I know it's AN Volt 10 because it's the white wire with the blue stripe. White wire, blue stripe. And we consult our... I've lost it. I'm sure it's up here. It is. We consult this and we find AN Volt 10 is a white wire with a blue stripe. So now that we have that on the correct thing there, we might be able to go to runtime values and see what that's doing. Maybe. There we go, runtime values. And we've got analog. We click on analog. Somewhere here, gear force. It's active. Really? It's not plugged in. Must be ready to go. There is one caveat. This may not go because it may be on the power supply from the fuel pump relay. In which case it's not going unless I turn that on. Not seeing anything. Yes, I am. Look at that. It's working. It should be about 2.8, somewhere around 2.8 at no load. It's pretty close to that. Depends on our voltage in our system, resistance across pins and all that sort of carry on. So that's pretty good. Pushing it forward, it's supposed to go down, I believe. That is going down, pushing it forward. There we go, pulling it back, it goes up. If it's going to function properly in this orientation, it can stay in that orientation. If I want it around the other way so that the wire's at the back here, it might be more suitable. So I can do that, it's no biggie. It's no biggie, quite happy. It's good, it's good, it's good, it's good. Not like the lens on my phone, which appears to be a little bit dirty. Right, these here that are orange, the power supply for those is coming from a fuel pump relay, which is currently off because the car is not going. This is why we are seeing a, go away, seeing a fault. It's not faulty, and I'll show you just for the sake of it. Oh, come here. It's not in motorsport. It's in, where is it, guys? Auxiliary outputs. It's going to be in fuel pump control. And we're going to test the fuel pump. Watch this. We're going to turn this on. Boom. They're good. They're happy. So we turn the fuel pump back off again. Now the computer thinks they're broken because it's not seeing any voltage coming back through the channels that it needs to use, wants to use to turn those solenoids on and off. So that's good. We've got circuits there. They'll function. Obviously the engine's not going to be rotating without the fuel pump going, so it's fine to have those on that system. It's not actually the same relay. There's two control, well, there's two orange wires here. That's the fuel pump relay wires. So I've hooked one and run it back to here to turn this relay on and off at the same time as the fuel pump relay, which is in the front there. That will probably change because I may run that on an ignition relay and then run the fuel pumps at the front on PWM, seeing as this computer can do that and the G4 Plus couldn't do it as successfully as what this one will be able to do it. So all in all, very happy. Good day, except we haven't got this puppy working yet, but we'll get there. That'll be something simple. It probably, I was nearly going to turn that off, and that would be very silly because we need to go in here before I keep talking and forget to do it. We need to store to the ECU, and we need to save the file. Oh, just put it back where it was. Initial tune, go. Yeah, just do that. Good, thanks. Cheers, bye. We'll turn that off. No, I don't want to do anything. Bye. I'll show you the distractions. What was I going to say? It would probably go if I plugged in the fuel pump that's in the front there that's currently is unplugged. If I plug that in and turn the key, I'm pretty sure this will fire up. I have not checked the spark timing, so I don't want to do that yet. I need to borrow an able-bodied person who can help me out to do that. Might be wifey. I'm sure she's capable of pushing. Ironically, the hazard light switch is actually the starter button. Yeah. Yes. Right. Thanks for watching, guys. Hopefully tomorrow we'll see this is working. I know it's not working. It's reading some figures, right? But it's not getting any figures from the ECU. And I know that's the case because it's telling me the inlet air temperature is 0 and the water temperature is 0. So we're not going to see any speed. We're not going to see oil pressure. And we're not going to see engine revs because it's not running, right? But we should be seeing water and inlet air temp. We're not. So currently this is not going. And when I search for CAN units in the system, it's not finding anything. I think it's a setting on the pinouts. I think everything else I think is probably okay, but this does not know to look for the two wires that run the CAN system. I think that's where we're going wrong. Maybe. We'll find out. Someone will know. Alright, cheers for watching. Thanks, bye. But wait, there's more. Ooh. We've got it working. Told you it'd be something simple. Right. Massive progress. Very, very close to being ready for the dyno. Yay!